Alright, here we go. Continuing on with our hypothesis significance test. Alright, our next situation says Nolan is an avid golfer who would like to improve his play. Mr. Weagle suggests getting new clubs and lets Nolan try out his 7-iron. Based on years of experience, Nolan has established that the mean distance the ball travels when it hit with his old 7-iron is 170. Alright, so that's old. With a standard deviation of 15. He's hoping that the new club will make his shots with the 7-iron more consistent. So he goes to the driving range and hits 50 shots with a new 7-iron. Alright, so let's do, I like to do hypothesis test first, it's just me. Alright, so let's do the correct hypothesis test. So I'm going to say HO. Alright, now, sometimes this can get confusing on what am I actually doing. Well, first of all, he wants to be more consistent. Okay? So, that means less variability, which means, what am I concerned about? I'm concerned about the standard deviation, which currently is 15. Alright? Does that make sense? I don't really care about the average length he hits it. He wants to be more consistent, which is standard deviation, right? Consistency would mean, if standard deviation would be 0, I would be hitting it the exact same way every time. Okay? So, my hypothesis is I want this guy, alright, I'm going to assume that these new clubs should hit at 15 yards. Right? Okay? Remember, the new clubs, Mr. Weagle's clubs might hit different, but I'm going to assume it should be at 15. Okay? Now my alternate hypothesis would be that the standard deviation, what do I want to know about? Okay? Well, he wants the clubs to be more consistent, which means a less variability or a less standard deviation, right? So if the old ones were 15, I want to see if these new ones will produce a lower than amount than 15. Does that make sense, guys? Lower than 15. Alright? Now, I know some people have this question about hypothesis tests, and they say, well, it's equal. This actually, yeah, it does actually mean more than or equal to. Right? Because if my alternate, AJ. If my alternate is just less than, then my null would be, equal to 15 or more, but we always just keep it equal. Alright? So that would be the correct hypothesis test. And then what would be the perimeter that I'm estimating? I would say sigma, let's make that a little smaller. We'll do it live. Is sigma is the variability of shots with the club from Mr. Weagle would be W-I-E. Alright, I-E-G-E-L. Okay? There we go. So the sigma, what is sigma? Well, it's the variability of shots with the club from Mr. Weagle. We're going to assume they will be the same, but we're hoping for a lower result in that case. Alright. So, we've got some homework situations. I'm going to scoot forward just a second. And if we look at the homework situation, for each of the following settings, describe the parameter of interest and state the appropriate hypothesis. Alright, so let's just do one more, just because I want to make sure you guys got it, alright? So, I like to do the hypothesis first. According to the website, sleep deprivation, 85% of teens are getting less sleep than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks a simple random sample of 100 students at the school how much sleep they got on a typical night. In all, 75 of the respondents said less than 8 hours. All right, so first of all, what should we assume before we even do the experiment? We should have our hypothesis picked out. So basically, even before we know any of this stuff down here, right? Just right up to the point where Janie wonders, she should be thinking, does my null hypothesis, or my HO, okay, now we're talking percents, right? 85%, so I'm going to do is say, is my proportion equal to 85? I'm going to assume it's the same. I'm going to go 0.85 if you guys are okay with that. I'm going to assume it's the same as the rest of the US, maybe world, I'm not sure what 85 just says of teens. And then my alternate, what is she actually wondering about? Just that it's different or that it's more or less? Says Janie wonders whether this result holds in her large high school. So she's just wondering if it's going to hold. So she's wondering if, not if it's less, not if it's more. She's wondering, no, basically, if it's just not equal to this, right? So that would be the alternate, would be that it's not equal. It could be lower, it could be higher, just that it's not equal to. All right, that's going to be a two-tailed test. And by the way, I'm not going to take the time right now, but P is the percentage of teens getting less than 8 hours. All right, so that would be the parameter. Should we do 3? Let's do it. It's part of the 2. Oh, no, we don't have time. Sorry, we don't have time. We got way too much stuff to do. All right, so, all right, it's going to be a little weird because we actually don't have people actually shooting in class. But let's say Evan, our good old Evan, he states that he shot a 42 in trash ball. Whoop, right? All right, we checked it out. So, what would be, I don't believe him, though. Evan, he's not the most accurate guy. No offense. He's just not. I mean, you can tell. Just look at him, right? I mean, he's got like a chipped tooth right there. Sorry. He's got a chipped tooth right there. I don't believe it's 42. However, what would be my correct hypothesis test? All right. Well, my correct hypothesis test would be HO. I have to assume he's right, right? So what am I dealing with? Percent. So I'm dealing with P is going to equal 42%. All right. And hopefully you guys are starting to get the hang of this. My null hypothesis, I'm going to say, is 42. I got to believe him. I got to believe him, right? Okay? However, I think he's lying. Okay? Now, I have not evaluated anything. Your null hypothesis should always be stated before you go out and gather data. It's just like, I'm wondering about this. So, I wonder, now I could do a couple different things. Do I just wonder if it's not equal to 42, meaning he could shoot higher or he could shoot lower? Or do I think he padded his results? I think he padded his results. So I think he actually got lower than a 42. Does that make sense? All right, that's my personal opinion. All right, that's what I'm going to test. Now somebody else might just say, I just wonder if he's lying. He could have gotten a really high score and wanted to make himself look, not as good. All right, so in class we'd have Evan shoot. Let's just say Evan shoots. All right, his sample. Let's just say his sample was a 34. All right. Okay. Let's say he shot it 30 times. Does that give me 10 successes, 10 failures? Yes, it does. All right. So let's say he shot it 30 times. All right. So in class, he's going to really shoot it. All right, let's check this out. Whoop, link. All right, so we are assuming he shoots. We have to go with, my bad. We have to go with the null hypothesis. We're assuming he's shooting a 42. All right, we have to assume that. Okay, so we're going to put in the probability of 42. All right, now we're going to have him. We're just going to sample 30 candies because let's say we have him shoot it 30 times And we see exactly what his percentage was. Now we know it was 34%. And let's just do, this is 1,000 ways. Let's go 10,000 ways. I don't want to animate this because that would be... These are 10,000 different simulations of him shooting it 30 times if his actual average was 42. Alright, so we're going to do proportion. And here we go. Alright, boom, there we go. Alright, does that make sense? So, I'm going to do something really clever here, guys. You guys are going to see some behind-the-scenes magic. Alright, and I am going to snap this right into my notebook. Alright. Now, this would be all the ways I could get it. If I truly get normally 42%, I could have some bad games. I could have some good games shooting 30 times, right? Not always going to land at 42. Now, in class, he shot a 34, which a 34 would be right around here, right? Does that make sense? Does this seem like a feasible score he could have gotten if this was true? Basically, if 42 was true, does it seem like he could get a 34? Alright, and this is basically where we're headed. And this would be like our p-value. Basically, how likely, our p-value would say, how likely is our event? You know, and I would say it's actually quite possible, right? There's quite a bit of information below this, right? And so I think he actually could be telling the truth. All right, so the p-value would be like basically, you know, how much information is below this. Now, if he shot something that was down here, if this was his example that he shot in class, I might think he lied, which would be like at 10%, right? If he only shot a 10% for his sample, I think, you know what, he probably wasn't shooting the 42. He probably was lying, because not many samples are below that, right? Okay. So, here are your two answers you can say. All right, you can say, Evan, I'm going to reject your null, meaning I don't agree with your null after checking out the data, right? I'm going to reject it, which means if I reject the null, guess what I'm doing, basically? I am accepting the AHA, right? Okay? We always phrase it in terms of the null, though. So we don't say I'm accepting the alternate. It's just I'm rejecting the null. And then the other option would be to fail to reject the null. I know this sounds like a double negative, right? Failing to reject the null would be I'm going to end up not rejecting this, right? So that means I'm going to accept the null, right? This actually means almost the same thing. Accept. And we're going to stop after I talk about this. All right? Accept. Right? It means almost the same thing. Fail to reject and accept. However, when you think about this, all right? And it's very important you should put fail to reject instead. All right? When you fail to reject the null, all right, we are basically saying I don't have enough proof to prove my alternate. So I am going to choose and say, okay, fine, I'm not going to call you a liar, right? Failing to reject says I'm not going to call you a liar, but could you still be a liar? Do we know Evan actually did shoot a 42? We don't know. He could have shot something other than a 42. He still could have lied to us. I just don't have enough information to prove it, right? And remember, when they have people in front of a jury, it's you're guilty, right? Or you're not guilty. They don't say you're guilty or you're innocent, because innocence means they didn't do it. And basically, they say you're guilty or not guilty. Not guilty means we don't have enough information to prove it. You still might be guilty. I just don't have enough proof. So we don't say accept, all right? We do not say accept. We say fail to reject. All right, guys. I'll see you next episode.